So hello, everybody. As John said, my name is Stefan, and I'm going to talk about DevSecOps in 2031. So this is going to be a bit of a futuristic talk, and it's a bit of an experiment as well. So let me know how you like it. My background is, like I mentioned, I've done a lot of hardcore security testing, which means I was actually in the early days doing security tests in networks, all of these things when there was no tools around. We had to write everything ourselves. And after being on the offensive side for many, many years, I got sucked into the secure software development and later on into DevOps and DevSecOps, which to me was a complete game changer because it changed my perspective on security as a whole. And while I was consulting with a lot of different organizations around the globe for introducing the DevSecOps practices, I also realized that the security automation piece is completely broken, in my opinion, and set out to fix it. And so since then, I've started a company called Guardrails.io, and I'm now the CTO there. And just a quick plug, we are actually just hiring dramatically. So if you are a hardcore security folk as well that wants to help millions of developers secure their applications and make security a better place, please do send us an email to careers@guardrails.io. All right, so now let's dig in. We're going to have our protagonist called Sam, and Sam is a security lead for a very hot new fintech application, and she got like full buy-in from the top level management, and she was there from day one to make sure that this project is going to be top-notch, secure, and that everything is going to be the best possible outcome. And so she was able to bring together a dream team of other security engineers and is working with the best in the industry that are developing and architecting this application. And they have an unlimited budget, which is great. So Sam was able to implement the best possible security approach that is state of the art for this application, for this project. And yeah, Sam is really awesome. Sam also knows that sharing is caring, and as part of being a community, you have to always make sure that you can bring these new approaches to your peers. And as such, she decided to share this in the local OWASP chapter. Her security approach looked something like this. First of all, we understand that security starts with developers, starts with the operation teams. And so Sam actually decided that every engineer, every person writing code, no matter if it's for the application, for the front end, for the API, for the mobile app, or for the infrastructure, they have to get through some form of traditional security training, which means understanding what is important, what is the important security, what are the important security goals of the application, what are the risks we want to avoid, what are risks in general. And then of course, they also started doing gamified security training, which makes sure that they could actually take existing vulnerabilities that they had in their application, and they also were able to actually use this in a gamified way to learn what are the problems they had, how do they fix it. And so this was to ensure that everybody at any time has a good baseline of security, understand what they want to achieve, and that really helped just make sure to set the stage. Then in addition to this, of course, because it's a financial application, threat modeling and agile threat modeling has been done for every sprint, making sure that the new features that are coming in are completely secure, and all of the adverse test cases are being considered and the threats are being modeled out. In addition to this, every user story also has to have security acceptance criteria, which may be something simple like what are the different authorization issues that we have to cover, what are the requirements for inputs, validation, and normalization, etc. And there were also dedicated security stories. For example, how does our authentication framework look like, and how do we make sure that this is done properly to authorize people, etc., etc. When it comes to selecting open source libraries, there was a very, very minimalistic approach taken, because we all know that open source software, there's a different level of quality, there's a lot of bugs being discovered, and we're building our applications on this foundation. So besides making sure that only respectable approaches are being used and languages are being used that are, more minimalistic and lightweight, there was also an automated security patch process in place, meaning not just when, like every time there's new security vulnerabilities available, automatically the pull request would have been created to make sure that this has to be merged before the next iteration will come, will be deployed to the as part of the application. And of course, we also understood, or Sam also understood, that license compliance is very important. So there was also, of course, gates in place to make sure that only libraries that are in line with the legal requirements that we have for the application could be actually introduced. In addition to this, we also made sure, or Sam also made sure, that in their team, every single commit that was being created would actually be scanned with static analysis tools covering everything from infrastructures, code configuration, your normal application code, secrets, you name it. On top of that, only PRs can be merged, no code can be committed directly to any of the repos, and they would require peer review. So at least two people would have to actually approve a PR before it gets merged to reduce the risk further that any of the like any malicious code may be introduced, or maybe some attacker gets a code in that could cause a could cause an attack against the application. Because everything was containerized in the microservices, there was also, of course, policies around containers, making sure that only containers with no high risk or critical risk CVEs could be deployed. And once everything was done, the deploy to the test environment would automatically trigger dynamic scanning. And of course, the application in the test environment have IAST enabled, which means you get a very good coverage that's also further orchestrated and exercised with the functional test suites that are running against it. In addition to this, we also, of course, had functional security tests that are running against the API. So in addition to the acceptance criteria that you would also have good and bad security tests, and every security test that was ever, every security vulnerability that was ever identified would have been coded as a failing test, and only when this was passing, it would have been able to continue. In addition, we of course also had manual security testing in place, which is penetration testing internally. And there was also security acceptance criteria testing, which means when a ticket gets approved, a security team member would have to make sure that all of these things are there and working as expected, not just from a functional side of things, but also from the security side of things. And in addition, chaos security experiments are being started, making sure that the system is not just reliable, but also secure, and that injecting failures would allow everybody to make sure that the response is ready, that these events would be identified, and everything would be managed the way it is intended to be. There's also continuous validation of the prod environment following the 3 R's of enterprise security, which means rotate, repave, and repair. Rotate means that all the credentials would never be static. They would always be automatically rotated. You also have, of course, the repave, making sure that your production environment is reset to a known state. And so there's no long-running containers, which also reduces the risk of making sure that attackers that may get in there, that they don't really have a foothold. Of course, the systems also have runtime application self-protection and next generation WASP in place. And on top of that, microsegmentation was being used, ensuring that every system can only communicate with another system in the approved way. So all the firewalls on these local machines were orchestrated to make sure you only have communication that is approved, even inter-services. And there's also a SOC in place that makes sure that there was extensive security monitoring, and they started looking at behavioral analysis, which actually Troy just mentioned in the last part of his talk as well, to make sure to see that not just people doing stuff is fine and they have the credentials, but also that doing the same things and the right things in line with the behavioral profile that we had. And finally, there was the bug bounty program, making sure that there's continuous security testing from third parties that make sure that everything else is hopefully identified as quickly as possible before hackers come in. So that was the beautiful thing that Sam has come up with. And Sam has been so happy with the results. The project was a huge success. They're in a really good position. There's almost no security debt. And not just the project members and the company is really happy. Her peers that she has presented this to are amazed with what she has brought up here. So really happy and content with herself. Sam is now heading home, getting ready for bed, when suddenly her future self appears. And her future self has a message saying that the world is at risk because something is happening and hackers are threatening to take over the planet. Sam's really confused with that. And just a disclaimer, we are not going to look into time travel paradoxes because they won't apply to the story. So what happened? In the future, 10 years from now specifically, a semi-sentient, continuously evolving hacker AI has escaped the lab and has been successfully attacking 95% of all the critical apps out there because they were not secured properly. And now future self says, hey, I know you have a lot of questions, but there's no time. So come with me to the future and I will explain everything to you. So Sam is coming with her and they arrive in 2031 and future self is continuing to tell the story. So first of all, you have to understand that you have done a great job with the project that you've just mentioned, which has led to amazing opportunities for you in the future. But it was also the main reason why I was allowed to join this task force to battle this sentient AI and make sure that we can actually be in a position to get ahead and change the history because we are losing the battle. So in order to continue now, we have to understand, even though the project that you have just set up and you've just released it, everything is looking great, you have to understand that there's actually a bunch of really important issues with the way that this is being done. Even though you are state of the art, the scalability of securing this is actually very, very difficult. You have secured one application, but you know this application is just one product of the entire organization that you're working for, and that this approach that you have that you have pioneered works really well here, and you've spent a lot of time, over a year actually, securing it. However, what about the rest of your portfolio in the organization? What about other organizations out there? Not everybody has the same access to talent, all of these other things, and budget to actually make that happen. So while it's a great reference, it actually is not allowing you to do this in a meaningful way and actually help everybody with this approach. In addition, yes, you have done a lot of automation on the tools, but lots of these tools are still very noisy and do take away a lot of time from developers to realize what is the problem here, and they do require a lot of tuning, which takes away a lot of time of making these things actually useful at scale as well. In addition, we actually have, there's a different set of tools, even sometimes for the same scanning techniques, and they are not well integrated together. So you have to actually write a lot of integration code and glue to make sure that you can get these different tools in there, that you can actually make sure that these results are the same. You have to deduplicate the issues if this the same kind of tools with the same focus on certain techniques. And that's also a big challenge to actually scale it up. And furthermore, correlation. You have been able to have like all of these different results for for issues in code, at runtime, in infrastructure, but it's not very clear how these things actually go together. How can you actually make sure that an issue in code correlates with this report from a bug bounty program that actually addressed it at runtime here? And how you get all of these things together is a big issue because applications are getting more and more complicated. Infrastructure is getting more and more complicated. So you have to be able to actually make sense of this in a meaningful way that allows you to address the risk in a way that makes sense and you can actually do the right things and focus on the right fixes. And finally, the adoption. So only high-performing companies with the right access to talent can implement this approach that you've been mentioning. And that's a real issue. So besides these things, a lot of these things that we have been talking about, like that we have been addressing in the last decades, will be something that is really important to actually get this battle sorted with the sentient AIs. So let me catch you up on what we have achieved in these 10 years as an industry and as a software development community to make sure that we can do the best in terms of securing applications. So first of all, in 2031, only type-safe, lightweight programming languages are being used, which means languages like Golang have really won because they were able to give you a very good, safe environment. They're easier to understand, they're easier to compile and check against, and they're super lightweight. And this is really important because you want to be able to make sure that your applications are very well maintained, and it's very hard to write something that's difficult, that's not clear from a type perspective, etc., etc. Another thing that was a huge change that we have influenced over the last decade is that open source software is not being used the way it's used today. When you look at your node modules and you have like hundreds of megabytes of libraries that do certain things, this was no longer viable. And so what has been done is we have actually started incorporating open source software in generally recognized as safe lists, which means there's like a hierarchy between open source software that allows you to select high quality, well-maintained, well-secured open source software to do certain things. And this was important to reduce the problem with supply chain risk, etc., etc. And also quite important is that a lot of organizations that use this open source software that is considered as safe, they actually give their own employees and full-time staff members to make sure that they actually can contribute in making this secure. So there's a lot of more work happening around secure open source software and funding that, because that's really what a huge attack vector was to secure. In addition, serverless and event-driven architectures have actually started coming up more and more, because you don't actually want to manage the infrastructure, host, or network security concerns, and you just want to be focusing on writing functions as a service and have this event-driven architecture. To be in a position where you can just make these changes, you can just focus on the features and you don't have to worry about patching the underlying application. And most importantly, we have made huge strides in AI pair programming. And this has led to a huge improvement in the quality and security of code. And Sam interjects, hang on, AI pair programming, isn't it like this OpenAI Codex project that it just released in August 2021? But this was like really bad, right? It created vulnerable and buggy code. So how did that actually happen? How did that actually evolve? And so, yes, that's exactly like that. Remember that in the early days, initially, the GPT-3 was not able to code at all. But there have been very quick changes and improvements where they started fine-tuning this GPT-3 model based on public GitHub repos. And even within a very, very short time, they were able to actually solve 30% of these programming challenges. And, going from 0 to 30, it was just a matter of time to go to 100% and even beyond that, if you will. So AI-powered pair programming and was just really one of the key things. And yes, initially, there was a lot of AI-generated code that was quite bad, because actually there's a really cool article that I've linked here as well. 40% of all of these scenarios that were created by, let's say, GitHub Autopilot in this case, they had contained security flaws. And this may sound really scary because if people don't know what they're looking for and they're not able to understand what this code is being generated for, it actually is going to be a big issue, and we will have a lot of insecure code. But funnily enough, this is the same bias that we have seen with racial bias, where facial detection works really well for Caucasian people, but not maybe for people of other races, because the data set was mainly focused on white Caucasians. The same is true with open source code and code that is being ingested by this model. So this was actually something where you can, with a little bit of fine tuning, you can make a huge strides in eradicating a lot of these vulnerabilities. And actually, this will be a result of eradicating entire vulnerability classes. So let's take a look at OWASP top 10 and how it's going to look in 2031. So I've just put in the picture here where you can see 2017 to 2021, a lot of changes have happened, right? And more importantly, there's 3 new areas, such as insecure design, software and data integrity failures, and others. But in 2031, there are no more cryptographic failures. There are no more injection level vulnerabilities. Security misconfiguration is gone. Vulnerable outdated components, no longer an issue, because these things are where actually AI can really help out, making sure that code level issues are being addressed. And secret injection has been around for way too long, for example. Same like cross-site scripting. And this is something where AIs can be very, very strong in actually reducing these vulnerability classes in total. However, when it comes to designing applications, broken access control, insecure design, and these kind of high-level business logic issues are very, very important, and they will still be a big issue where humans have to work. But yeah, great news. Finally, those pesky secret injections are gone. Who would have thought? All right, and other things that have changed now in these last 10 years. Auto-fixing of the most code-level vulnerabilities, like insecure configuration, has been mastered with the help of AI, like we said. But get this, there are no more dedicated security pipelines or actions or whatever you want to call them. What has happened is that there's full stack scanning that is triggered by relevant workflow events. So think about it this way. You don't have to, like, every pipeline you're looking at, besides maybe they're using different tools from different vendors, they look exactly the same. You're checking code, you do something that looks at the code level vulnerabilities, you deploy to a test environment, you start your runtime testing. So all of these things are the same. Sometimes you use action for sub things like only secret scanning, etc. But actually that doesn't make any sense because it's a solved problem. You just have to integrate it into the right eventing workflow events, such as code is being pushed, system has been deployed, a new instance in your cloud environment is coming up. And based on this, the right tools will actually be triggered automatically. So you don't have to mess around with pipelines. You can just really get started and focus on building great software. And these security tools will just scanning and give you the relevant feedback in your workflow anyways. And finally, education is also fully integrated into the workflow, which means every time there's security issues being identified, there's nurturing campaigns that actually make sure that developers learn about these mistakes until they really get it in a meaningful way and make sure that these things are being eradicated on an ongoing basis. So that sounds really great, actually. So what is the problem? What do you need me for to change in 2021 to make this problem go away? So the problem is that even though in the future we have much better solutions now, many organizations, small and big, still have a very, very hard time adapting these new technologies, which means automation on the AI side, we still need a lot of people to help organizations improve their workflows and actually implement the change. We still need people to understand exactly what the problem is and how to address it, even though it will be augmented with automation and AI. So I need you to help spread the word. We got to make sure that there's smart automation and workflow integration. We can't be wasting time with pipelines, and we got to have seamless feedback for developers at the right time. Also, auto-fixing and repairing of code. This is something that is just going to be boosting the productivity of any team you're on and helping with the shortage we have for talent already. And this will start with using rules to make sure that you can actually fix very simple patterns, but then over time, the AI will be able to leverage this. So make sure that you can actually work on these things and make sure that this auto-fixing is being really streamlined and fast-tracked in combination with the smart automation. Make sure that generally recognize the safe list for open source software projects will become something that the community as a whole is working on. Because then we're going to have the key projects that are backed and secured by companies. Similar to OWASP flagship projects, the same thing should be available for open source, where you can really focus on building high quality open source and have like a pre-filtered list of things that you can actually select with a high level of confidence that there's no surprises in there. And finally, embrace machine learning and AI. It will make our jobs easier, but we still need a lot more people and talent to help secure our world. And this is, like I said, to make sure that they understand applications, they understand security, understand what the product actually does, and make sure that AI and automation is being used in a meaningful way so that we can focus on the high impact issues that actually are fun to work on, and we're not wasting time looking at yet another cross-site scripting. And with that, I leave you back to the present in 2021, and wish you all the best. Anyways, thanks. This was my presentation. I hope you enjoyed it. It was a bit of an experiment, like I said. So if you have any questions, ask me on Slack or shoot me an email at stefan@guardrails.io. Thank you very much.